Space, the area between particles. These are the experiments of the physicist Rutherford. His life mission, to disprove plum pudding, to seek out the positive center of the atom, to boldly discover what no man has discovered before.
After Dalton's atomic theory was proposed, scientists came to believe that elements consist of atoms and that compounds are specific collections of atoms bound together in some way. However, the question remained, what is an atom like? Is it a solid, or is it composed of various parts? If it's composed of various parts, otherwise known as subatomic particles, then there should be some way to break the atom into its components. In the late 1890s, an English physicist named J.J. Thomson showed that atoms of any element can be made to emit tiny negative particles, which we now know as electrons. However, Thomson knew that the overall charge of the atom was neutral. Therefore, he concluded that there must be positive particles in the atom to balance the negative charge of the electrons. Here's a clip of J.J. Thomson demonstrating his phenomenal discovery.
Lord Kelvin, another physicist from the UK, believed that an atom might be something like plum pudding. He thought that as raisins in plum pudding are randomly distributed throughout the pudding, so are electrons randomly distributed throughout the atom. He believed that the atom was a pudding of positive charge with enough negative raisins within to create a neutral charge. For a number of years, this plum pudding model was the standard model of an atom. Now follows an attempt to make plum pudding.
I'm so happy, oh, lucky me. I just go my way, living every day. I don't worry, worrying don't agree. Things that bother you never bother me. Things that bother you never bother me. I feel happy and fine, ha-ha. Living in the sunlight, loving in the moonlight, having a wonderful time.
In 1911, a physicist named Ernest Rutherford changed how we view the atom forever. In his study of the flight of alpha particles through the air, he noticed that some of them were being deflected away from their target. To discover what was causing this, he designed an experiment which involved directing alpha particles toward a thin sheet of gold foil. A detector around the foil produced tiny sparks wherever it was hit by an alpha particle. He was shocked by his results. He expected that the massive alpha particles would crash through the foil like cannonballs through paper. At least, that's what would have happened with the plum pudding model. Instead, some alpha particles were deflected at wide angles after hitting the foil. He concluded that there must be a dense, positive mass at the center of the atom to repel the positive alpha particles. Rutherford also concluded that the atom is composed of tiny negative electrons moving in empty space around the dense positive nucleus, creating a neutral charge. In this way, the concept of the nuclear atom was born. Several years later, Rutherford discovered that protons in the nucleus of an atom have the same magnitude of charge as electrons, only positive. Several years after that, Rutherford and James Chadwick discovered that nuclei also contain neutral particles called neutrons. Altogether, these subatomic particles created a neutral nuclear atom. Hey everybody, so here is the plum pudding that we attempted to make earlier. This is what Lord Kelvin thought that the atom would be like. Yeah, beautiful atom, right? So we're going to see if this will come out of the pan.